Good evening, everyone. So what we're doing here is we're going over the angles of elevation and depression worksheet. Because the front of this worksheet works as a kind of catch-all for trigonometry, I'm going to go over a couple of each one. So starting with number 2. So as always, what I would advise you guys to write up at the top of the paper would be so ka toa, and then this, and we're going to put Andy right there because Andy always hangs out on the corner of hypotenuse and adjacent. So katoa stands for 3 trigonometric functions. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this is how this is going to work. We have basically the same set of steps that we go through with each one. I'm currently talking while pulling up a calculator. So what we're going to do is wherever we see this angle, we're going to put Andy. The hypotenuse is always directly across from a 90-degree angle. And as I said up here at the beginning, wait for it to, oh yay, it just disappears. Okay. Andy is always on the corner of adjacent and hypotenuse. So we come back over here. So we know this is the adjacent, and that makes this the opposite. So then we look and we go, okay, so what two sides do they give us? And here they give us opposite and adjacent. So we go up here and we go, okay, which one of these three has the O and the A in it? And it's this one right here. So it's tangent. So we know that the tangent of any given angle is equal to the opposite over the adjacent. So what we're going to do here is we're going to fill in. We go tangent of 62 equals x over 25. Remembering that any of our trigonometric ratios are just that. They're just ratios. So we know that any given 62, 28, 90 triangle has the same proportion of sides as any other 62, 28, 90 triangle. And the relationship between the side opposite the 62 angle and the side next to the 62 angle is constant. We're calling that the tangent of 62. So we're just using fancy words to describe the theory and application of similarity that we already know. So here, multiply both sides by 25. So that's going to give us 25. Tangent of 62 equals x. And if you have a calculator like the one we're using at school, that's all you do. Just type in 22 tan 25 tan 62, enter. I'll give you the answer. A sip of coffee. And we get 47.018. Now this says we're rounding to the nearest tenth. So x is going to be 47.0. Because we're rounding to the nearest tenth, we want to keep that 0 in there. We don't just say 47 if it asks for tenths. We put that 0 in there. Number 5, kind of going to do the same thing. Set up right there. That's where Andy stands. We know this is our hypotenuse right across from our 90-degree angle. Andy is always standing on the corner of hypotenuse and adjacent, so that makes this our opposite. Here we have the A and the H. So we go back up top and we go, which one has the A and the H? It's this one right here, cosine. Okay. So we go the cosine of any given angle equals adjacent over hypotenuse. So we go the cosine of 12 equals 29 over x. Now notice we can't just do the same thing because the x is in a different spot. Previously on question number 2, the x was in the numerator of the ratio, the fraction, and here it's in the denominator. So what we end up doing here is we go x equals 29 divided by the cosine of 12. So notice over here in number 2, where x was in the numerator, we went 25, that's the known side, times the tangent of 62. Here, where it's in the denominator, we go 29, the known side, divided by the trigonometric ratio, here the cosine of 12. So what we're going to do is we're going to go 29 divided by the cosine of 12 equals, and we get 29.64. Again, we're rounding to the nearest tenth, so we're just going to go 29.6. And that's that. Okay, so moving on. Let's look at number 7. So number 7 here, notice that we've completely switched it up, and now we're missing the angle. Now the process of setting this up is the same. We're just going to do something a little bit different with our calculator. Andy, as always, standing right there. Figure out which one's the hypotenuse. We know that Andy stands on the corner of hypotenuse and adjacent. That makes this the opposite. What two sides are we given? O and A. Go look up back top, and hey, we got tangent again. So here, we know that the tangent of an angle equals opposite over adjacent. Now here, the variable is that x right there. We know that's going to equal 19 over 23. So I'm going to break this down a little bit more than I normally would because, frankly, from here on out, you can actually do the whole thing on your calculator. I'm going to go 19 divided by 23. And I get 0.862. Sorry, 0.826086957. 0.0. Nope. Erase that. 0.826. And so on and so forth. So now what I'm going to do is I'm going to use my calculator and say, hey, listen, I know only one angle has this as a tangent. So, oh, please, calculator, tell me what that angle is. And here's what we're going to do. We're going to hit second tangent, second, and then on the bottom right-hand corner of your calculator, there's this little button. And what's going to pop up on your screen is this. Tangent to the -1 answer. You hit enter. And you get 39.55. So x equals 39.6. Now you can check this. You can go 39. You can go, what is the tangent of 39.6? You have 39.6 tangent. We get 0.827, which is pretty darn close. It's not going to be exact because it was an irrational number. We didn't write out the whole thing. But okay, so that's how you do. So these 4 are grouped together. You're missing a side. And these 4 are grouped together. You're missing an angle. So the ones that I did like this, that's how you're going to do 2, 3, 4, 5. The ones that I did like this, 6, 7, 8, 9. So, word problems. So the important thing here is first and foremost to understand angle of elevation and angle of depression. So I'm going to draw a little bit, erase it, and then we'll do one of the problems. The angle of elevation is always a straight line out from the viewer, and then it's going to go up. And this angle right here, that's my angle of, that's an angle symbol. I'll do a better job. So this is my angle of elevation. Start here and go up. Okay. Now, when I'm looking down at something, this right here is my angle of depression. If you look at the problems, the first, I think, 3 or 4, the first 3 are all angle of elevation, the last 2 are angle of depression. It's really important that you get where the angle of depression goes. A lot of people like drawing, oh, he's here and he's looking down at something here, so this right here is the angle of depression. No. That's bad. Don't do that. Angle of depression starts here, it's straightforward, and then swoops down. Okay. Okay. So I'm going to pick one of the harder ones. You're welcome. And that's 11. So I'm going to do 1 depression, 1 elevation. So the angle of elevation from the top of a 95-foot tall building to a hot air balloon in the sky is 76 degrees. If the horizontal distance between the building and the hot air balloon is 354 feet, find the height of the hot air balloon. So let's draw a picture. Always draw a picture. It's really helpful. So here we have our 95-foot tall building. So this right here is 95. Okay? And I know that there is a 354-foot horizontal distance. And from there, there's an angle of elevation of 76 degrees, drawing not to scale. And up here, there's a hot air balloon. Here, we'll get super fancy and we'll put like a little fire right there. See? Here, we'll even put Andy up there. There you go. Andy's right there. And Angie angle is right there with her ponytail. And there's fire. Okay, all good to go. So what we want to know, now this is really important that you read the question, because what we're looking for here is the total height. How high is that hot air balloon off of the ground? So keep in mind that when we use sine, cosine, or tangent, what we're going to be finding is this length right here. So if I call this x, our ultimate answer is going to be x plus 95. Because our horizontal is starting 95 feet in the air. So now that we have this, I can draw my little reference triangle. Right there. Okay. So this is 76 degrees. This is 354. So now we just solve it like we did above. Here's Andy. I know this is my 90-degree angle, so this is my hypotenuse. Andy's always standing on the corner of hypotenuse and adjacent, so this is my opposite. This right here, that's what I'm looking for. So I have opposite and adjacent. Now, 7 out of 10 times, if not more, when we do these angles of elevation and depression, you're going to be looking at tangent, which this one is. It's opposite and adjacent. So we have the tangent of 76 equals x over 354. Multiply both sides by 354, so we get 354 tangent of 76 equals x. And we get, what are we rounding to? Just the height? Okay, we're going to go to the nearest foot. 1,4. Now we get 109.8, so we're actually going to round up to 1,420 feet. Now remember that means that this hot air balloon is 1,420 feet above my building. So to get what it is above the ground, we need to add 95 feet back in. And so we get 1,515 feet. And that's how high the hot air balloon is. Okay. Angle of depression. Let's do the surfing one. I want you guys to try the cell phone tower one by yourself. So a surfer is riding a 7-foot wave. Yeehaw. See, this is surfboard. This is the wave. Whoosh. This is the ocean. And this is the sand. Okay. So we know that he's riding a 7-foot wave. Now again, this is really crucial. It says that the angle of depression from the surfer to the shoreline is 10 degrees. That does not mean that this right here is 10 degrees. No. Remember what we're doing here. Oops, my wave disappeared. Now it's just hanging in the middle of the air. That's unfortunate. Here you go. So remember what we're doing is we go straight out from the surfer down here, and this right here is my angle of depression. That's 10. So when I do a reference triangle, this is 7, this is 10, and I'm looking for the distance from the surfer to the shoreline. So what my x is actually going to be right there. Because if I went right there, that would just put him, well, 7 feet above the shore, and that is painful. So if I've got Andy standing right there, this is my hypotenuse, that's the adjacent, that's the opposite. So I'm dealing with hypotenuse and opposite, that's sine. If you're ever concerned, just scroll back up to the top of your page. Right here, opposite and hypotenuse, sine. So you have a sine of 10 equals 7 over x. As I said before, when that x is down on the bottom, we're going to switch it. So you go x equals 7 divided by sine 10. And we get 40.3 feet. Okay, and that's it. So if you have any questions about this, you can ask me tomorrow when we show up, but try and get early because I really do want to get going on law signs first thing in the morning / actually morning. I'll have you guys come in the morning. So see you guys tomorrow morning. Bye.